back to soils and the environment. We're going to look at soil taxonomy today, and basically soil taxonomy is basically looking at the names of soils and being able to classify a soil based on certain characteristics that you observe in that soil. Soil taxonomy is mainly used in soil surveys, and you'll find that from our web soil survey application that the majority of the soils in the United States have already been mapped. That's incredibly useful, not for us to classify soils, because that's the job of the people in the web soil or in the soil survey of the USDA Natural Resource Conservation Service. But when we know what kind of a soil we are looking at from that soil survey, we can deduce properties of that soil based on what its name is. So that's extremely useful and important. There are some caveats that I'll talk about when we look at the soil survey itself. But for now, let's go ahead and have a look. Just going back, it's really useful when you want to buy a piece of land, whether it's for a house or for cultivating or whatever it is. You're able to know an awful lot of what you're letting yourself into when you understand what the soil is. We're going to look at soil taxonomy from a non-soil scientist perspective. It's like learning a new language, and the syntax, if you will, that is simply the 6 categories in soil taxonomy. The vocabulary that you have are those formative elements, and you will see a number of them in Conker and Fransmeyer chapter 10. And the formative elements are usually syllables that have a certain meaning or sometimes no meaning at all. Now I've added a few of those formative elements in here, and that should give you enough firepower at least to understand what soil scientists are saying. But when you're reading a book or reading a journal article or talking to a soil scientist, you want to go back to your phrase book, if you will, to be able to understand what that book or journal article or soil scientists are saying, and you will then be able to understand from that common soil classification some of the properties of that soil. So soil taxonomic names, when you first see it, it's what is this? What is this about? And so let's take a series called the Dalbo series we find up in the north. It's a fine smectidic, frigid, aquatic hapludolph. So if you look at that, it's like, what are they saying? The Norfolk Series, which we find down in this part of the world, all the way up the coast to Virginia, it's a fine lomicaline thermic typic candy udalt. So again, it's what kind of crazy naming is this? The objective of today's talk really is to kind of walk you through the nomenclature of these things, so that when I say, or when you encounter something like that, you'll be able to say, okay, I don't know exactly what it means, but I know where to look it up, and I know then how to deduce some of those characteristics. Right, let's go back. Remember what I said, your syntax over here is that there are 6 categories in soil taxonomy. Let's go to those 6 categories. In the United States, we have 12 soil orders, or 12 orders, 64 suborders, 300 great groups, 2,400 subgroups, and somewhere between 2,400 and about 10,000 families, and then something like 19,000 soil series. So in the previous slide, you saw a Dalbo or a Norfolk. Those are soil series and typically named after the towns or places that they were first discovered. So 19,000 soil series in the United States is a huge amount, and each one of those soil series really is a soil that looks if you saw a Norfolk in South Carolina and a Norfolk in North Carolina or Virginia, you'd be able to say these are some of the common qualities that those soils will have. So let's go have a look and take the Norfolk Series as an example of how to kind of unpack this nomenclature. The Norfolk Series is a fine, loamy, kaolinitic, thermic, typic candy udot. So if we look at our syntax actually starts at the end, and it starts with this syllable, alt, U-L-T. So what does that mean? That alt actually is related to the order name. Remember, there are 12 orders in the United States. That is related to the order name Altasol. You see those first three letters? Altasol is part of that candy udot. Okay, so soil order nomenclature is based largely on the soil forming processes, or CLORPT, and the presence or absence of major diagnostic horizons or soil properties. In other words, there's something very distinctive in one of those soil horizons that's going to give that soil a very distinctive property. I'm going to just very briefly show you there are two resources that the USDA gives us, the USDA Soil Survey. I'm going to just back out of this for a moment. And the first is just a whole soil taxonomy web page. For instance, there's a text that's about 800 pages, but there's soil taxonomy maps that you can look at if that interests you at all, or if you want to sort of dig deeper into it. So we've got this map, but it gives a number of different resources if you are so interested in that. The official soil series description, I like this quite a bit because I can search, for instance, go to that search page and go and enter Norfolk. Okay, so there we go. And I process that, and well, here it is. Norfolk is a fine, loamy, kaolinitic, thermic, typic candy udot, and I can view the description of that Norfolk, and it tells me all of the properties that you will find in a Norfolk cell, which is pretty impressive. These soil scientists, mainly guys who started out with a geologic background, were able to classify this information, and it's been of tremendous use in this country. You can then also view the extent map, and if you view the extent map here, you will see that, okay. All right, so you can view, if you view the extent map here, you can see that Norfolk basically is found across the southeastern part of the United States. So that's kind of a good resource if ever we were interested in looking at the properties and extent of a particular soil. So much for the USDA resources. If you need to go there, you know where to go now. Let's go back over here. So our soil order then is always that syllable in the last part of this very, very long name. So let's have a look at what soil orders look like. If you look at the dominant soil orders in the United States, you will see different, obviously these colors mean different things across the United States. In the eastern United States, we have Altasols. Alt usually means sort of advanced in process. These are soils that are weathered mainly because we have warmer, wetter climates, and so they're a lot more weathered than soils, say, in the Midwest. The mollisol is the soil that is most famous for in the Corn Belt. It has a very, very thick topsoil, or what we call epipedon. It's a molic epipedon. It's mol is the word for soft. If you talk about mollifying somebody, you're kind of calming them down. And so mollisols are in this area. Other soils that you might find in South Carolina, on the coast you'd find spodosols. You also find things called histosols. Histosols are soils that have very, very high amounts of organic matter in them, upwards of 20%. And we talked a little bit about Carolina Bays. Carolina Bays would have that. We also have in this part of the world inceptosols. Inception means, or when we think about inception, we think about early, and there are some inceptosols in North Carolina where you have the Blue Ridge Mountains coming out, and there are a few more in this area which we'll be able to find, of course. Okay, so let's leave it for that, because we can have a look at some of those names. The formative elements, or those syllables for the soil taxa, are usually derived from Greek, Latin, or other languages, or sometimes they're actually meaningless. So each formative element really defines a specific part of that taxon. So looking at the formative elements of those 12 soil orders, I'm not going to go through each one of them, but some of them make sense, some of them don't make at all any sense at all. But for instance, when we talk about ultisols, the Latin is ultimus, or last, ultimate. We talked about it, it's well developed. Oxasols, for instance, are soils that are found in tropical areas in Africa and Asia, where the soil has been weathered to an even greater extent than our ultisols over here. So a lot of the calciums and magnesiums have been washed out, and the soil is highly acidic. Mollisols we've talked about, histosols we've talked about. So these are some of the soils that you're going to find, and let's have a look at each one of them very, very quickly. So if we're looking at them alphabetically, if you want to actually go and get a map of these and pictures of them, you're welcome. It's going to be at the at this URL over here. But iridosols are going to be dry and very, very much common in desert environments, going to be out in the west. Okay. Alphasols over here are moderately leached soils with a subsurface zone of clay accumulation and greater than 35% base saturation. Base saturation is something that we'll look at later on, but it's related to the cation exchange capacity. And if you have greater than 35% of base saturation, it means that you have greater than 35% of your cation exchange capacity sites are occupied by calcium, magnesium, or sodium ions. Those would be some of your base ions. There's one other ion which escapes me right now. Entosols, you will see that there's very little morphological development on these entosols, and it's very difficult to distinguish from one soil horizon to the other. Andesols are soils that are specifically formed from volcanic ash. A place that you might find these are out in the west, where you have places like Mount St. Helens, or possibly in Hawaii, where you have a tremendous amount of volcanic ash that's come out of, that's historically been there. Gelisols are, when we think about gelati, the Italian word for ice cream, well, there it is, gelisols. In this case, you would have gelisols where you have permafrost within 2 meters of the surface. So these soils are cold, and you would imagine that not much in terms of soil formation has happened in here, simply because so much of the time there's a lot of ice around, and so you don't have that much in terms of shrink swell or plant growth. Your plant growth is mainly going to be things like lichens or something like that. Inceptosols, we'll find some of these in the Blue Ridge. These are very weakly developed subsurface horizons. Relatively speaking, from a geological perspective, they are going to be young soils, and so they're at the inception of their formation. Histosols, I talked about these as well. They're organic soils, and we would find them in Carolina Bays in South Carolina and North Carolina for that matter. The mollisols are these grassland soils. Remember, I think it was last week when we talked about grasslands where you had these grass roots that grew down maybe 5-10 foot into the A horizon and sometimes into the B horizon, the subsoil. And when the grasses die in the winter, the roots often would die as well and become organic matter. And so these mollisols are the grassland soils, very, very high base saturation, very, very high cation exchange capacity. That means that they can, they can hold lots of cations. Cations, potassium, of course, is the most important. Potassium, calcium, magnesium, and sodium. Extremely fertile, and you'll find the mollisols, if you go back into that soil order map, the mollisols are going to be in your corn belt. That's where they grow the most corn. Very fertile and holds a huge amount of water as well, because they're these deep A horizons. The oxasols are intensely weathered soils found in tropical and subtropical places. I mentioned Africa and Asia, but South America as well. So, for instance, a lot of the soybeans you find that are grown in the Amazon basin, for instance, are on oxasols. So they've got to deal with some of these fertility issues. Very intensely weathered. Altisols are also intensely weathered soils, but nothing as bad as oxasols, but as a result of very warm, very wet weather. In this case, the clays have less than 35% of base saturation. In other words, less than 35% of your cation exchange capacity is taken up by some of these by these cations: potassium, magnesium, calcium, sodium. Spodosols are kind of odd soils, and they're formed usually under acidic forests, in sandy dune swale kinds of areas. You'll find spodosols down in Charleston, and what happens is that you have a very thin A horizon. You can see that E horizon, and then you'll find that a lot of your metals, your ions, your minerals have leached down into your B horizon and sometimes even your C horizon. And often this might be, you might have a very strong deep E horizon, and then after a while, maybe a 2 or 3 foot, you'll find this strong layer over here of where your clays and your minerals have accumulated. And then your vertisols are soils that have very high clay content, and you can see they have extremely high shrink swell capacity. So the clay contents in this case are not clays like we would find in the southeast. In the southeast we have kaolinitic clays which don't shrink and swell much. These clays shrink and swell a lot. It might be, those names escape me right now, but we're going to talk about that in some clay mineralogy later on. But these clays are layered in such a way that water and minerals can actually come in between those layers, and when water comes in between those layers, it actually expands it. So that clay then expands, and when it shrinks or when it dries, it's going to shrink and form these incredible cracks. So those would be vertisols. So much for the soil orders. You then start to look at going back to the Norfolk series. The Norfolk, if you just look at the suborder name, is, remember the order name was alt, the suborder name is now going to be, it's a udalt, okay? So UD refers to the fact that it is a udic soil. It's the wetness of the soils. So suborders are subdivisions of orders that are based on wetness, soil order regimes, soil temperatures, the nature of the parent material, possibly, or the degree of organic decomposition in those organic soils. So the udalt is an altersol in the udic moisture regime. So let's go have a look at that map and see what it looks like. Other suborders found in the altersol area are going to be aquilts. So aquilts, you can imagine, are aquic soils, soils that are very wet in the altersol range. Eustilts, which are going to be soils that are not quite as wet as udalts. Xeralts, which would be soils that are altersols but in xeric environments. And humalts, humic would also, I think, really, it's not histic, but it would have a lot of humus, I think. I'm guessing now on that one. But soil moisture regimes that we can look at, you can see the udic moisture regime. So that green part is going to be across the mostly the eastern part of the United States. The aquic moisture regime going to be down the Mississippi Delta area, up in the Minnesota, I guess, lake regions, and then of course down in the southeastern seaboard as well, these coastal plains. So those are some of the major soil moisture regimes in this country. What you now begin to go over here is the eustic. We talked about those moisture regimes, I think, in the second week. And then we get into the xeric and auritic soils over here. Remember, the xeric is going to be mainly the Mediterranean kind of climate where you have cool, wet winters and warm, dry summers. And then, of course, the auritic is going to be places like Arizona, where you have year-round, you have very little rain at all. So that kind of gives you that soil moisture regime look. Again, you can go to your maps for that. So other soil suborder names might be, for instance, if you have a mollisol out in the west, you may have an albol. Albic, I think, if you think about an albino, albic would be a fairly light-colored soil. Aqual would be a mollisol that has an aquic component, very wet soil. Gelol, for instance, would be a mollisol that is, gerols and cryols would be mollisols that are extremely are cool. The same thing with some of these other soil orders that you see. So you can derive, take a look at these and see if you can derive from what they're saying from these suborder names, what kind of soil properties you might infer from them. So some formative elements of those soil suborders, again, you can go to Conker and Franzmeier and you can have a look at some of these formative elements over here. I think Conker and Franzmeier does a good job of talking about soil taxonomy as well. In fact, that's where I really was able to understand soil taxonomy a little bit better. So now we're looking at the great group name for the Norfolk series. So the great group name for the Norfolk series would be Candy Udalt. Okay, that means the great group name is a prefix for the suborder name. So actually, so the great group name, in fact, would be this Candy over here. So what does that mean? In this case, Candy is a prefix for a for a soil that has a candic horizon, meaning low activity clays. We have low activity clays in this part of the world. They're 1-to-1 clays. They're kaolinitic. They don't really shrink or swell, and they're fairly tight, and so they don't really allow that much in the way of cations to come in between each of those layers. So that's what we mean by a candic soil. So Norfolk series would be a Candy Udalt. So going back here, each one of those, this syllable, and then this, if you like, these two syllables carry with them very specific meanings. Okay. Some formative elements for great groups now. Let me just go back and so these are descriptions now of the suborders or prefixes. Argillic would be a white clay, so you might have an argillic horizon, a cambic horizon, a durus or a durable horizon, a duripan, which might be a hard pan. Hapless horizon would be minimum or not very well formed. Ocric, often meaning pale. Pale or paleos, meaning old. So again, you can see some of these formative elements, and again, these become part of your phrase book in being able to classify soils. And again, go to Conker and Franzmeier to make sure that you have that phrase book down. Now we look at the subgroup name. The Norfolk series is a typic Candy Udalt. The subgroup name is found by adding an appropriate adjective. So typic would mean, in this case, a typic adjective is this would be typical for this great group, you know. So if you look at a whole lot of Candy Udalts, the Norfolk series would be typical of many of those Candy Udalts. Now you're starting to look at the family name over here. We're at the 6th. So it's 1, 2, 3, 4, 5. This is your family name. It's designated by modifiers that describe particle size, distribution, minerality, temperature, and also how this soil may respond to management. So in this case, our family name, or the modifier over here, is going to be your fine loamy kaolinitic thermic modifier of this typic Candy Udalt. I hope this makes sense over here. So your Norfolk series is fine loamy kaolinitic thermic typic Candy Udalts. So let's go back again. The alt over here is less than 35% base saturation. That's probably one of its main qualities of these these altosols that you'll find in the southeast. Very, very well, very, very well weathered soils, developed soils. The Ud over here, it's Udic soil moisture regime. The soil moisture control section is not dry. It's basically a wet soil, and there your qualification of that is. It has a candic horizon. It has a very, very low, or the The clays in the subsoil are going to be low activity. That means they don't react as well as some of the soils that as some of the clays that you'll find up in the northern part of the country, in the Corn Belt. It's typic, and in this case, the surface thickness ranges from 0 to 50 centimeters or 20 inches. So that's typical for what you would find in a candy udalt in this part of the world. It's thermic, meaning that the annual soil temperature is 15 degrees C to 22 degrees C. It's kaolinitic because it's greater than 50% kaolinite. That is a specific mineral that we talked about, that low activity clay. And then finally, it is a fine loamy soil. That means about 18 to 35% of is clay in that subsoil control section. Again, I'm not expecting you to be able to sort of learn all of these things off by heart, but if you were in an exam, I would either give you all those phrases that you needed to basically, if I gave you a soil description that looked like this, I would expect you then to be able, from that soil description, to be able to build up this name. Remember, your series name begins on the right hand side, so it begins in a sense at the end and you build it up this way. So as you go up this way, these things become more, if you like, more and more common, more and more descriptive of many different types of soils, where over here your soil orders begin. So I hope that makes sense to you. So here we go. We're going to revisit this again, but your syntax is the alt is your order name, your suborder name is not necessarily 2 syllables, 2 syllables, udalt over here. Your grade group is a prefix added to the suborder. In this case it would be candy. Your subgroup is an appropriate adjective, it's typic. Your family name is going to be that modifier demonstrating or designating your particle size, distribution, mineralogy, temperature, and maybe management regimes. So for your vocabulary over here, so that's your syntax. For your vocabulary, go to Conquer and Frontmire chapter 9, or you can look at this link over here as well, where you might find, well, you find several hundred formative elements. I would say, you know, usually if you're operating in a particular area, it might be several dozen formative elements that you really would need to know if you were operating in soils. So why would you use soil taxonomy? Well, you'd want to use it to classify a soil, but for you, you're not going to be, none of you is going to become a pedologist, so probably not. But from understanding that soil, you can deduce properties that form a soil based on its classification. And so, without even going to that site, if you're fairly confident that a soil is a fine loamy, typic, thermic, candy udalt, you'll know more or less what that soil is. So soils can kind of be related to one another like kissing cousins. I just wanted to maybe just go over here to the official soil description just to kind of give you an idea in the soil series name search. So let's look at say an aley soil. Whoop, that's not much good. Excuse me. Aley soil is a loamy, kaolinic, thermic, arenic can hapludalt. So if you look at that description, you'll see that this is what the aley soil might look like. So this is a can hapludalt versus Norfolk, which was, or a candy hapludalt versus a Norfolk And what was the Norfolk soil order or name? Let's go back here. The Norfolk was a typic candy udalt, and the Ailey is a renic can haplodont. So, then you can view those descriptions. I'm trying to think of one other soil order. Let's go back here and look at a Cecil. Cecil is a very common soil order, a soil series in the southeast, in the coastal plain. It's a typic can haplodont as opposed then to the Norfolk, which is a thermic, or it's also a typic can haplodont. So the Norfolk and say the Cecil are cousins, although you will never not find the Norfolk, for instance, up in the Piedmont. You'll find it in the coastal plains, whereas the Cecil you'll find it typically up in the Piedmont. Let me do one more here. Rains soil is a wet soil that you'll find in the coastal plains. So let's go to the rains. Is a fine loamy, siliceous, semi-active, thermic, typic paleoqualt. All right. So paleoqualt, which would mean it's an older soil. It's an aqualt, which means it's got an aquic component to it. It's wet, and of course it's an altisol. So I hope that has given you a reasonable idea of soil taxonomy, and well, we'll find out during the exam, and I'll also give you some exercises in homework to figure this out.